Hi everyone. We looked at a bunch of factoring methods. So now it makes sense to talk about strategy. When do I use what method? In general, it's hard to say follow this particular procedure because it's kind of like you need to look at it and think about, oh, this is what I can apply, this is what may work. Sometimes you have to try, and then if it doesn't work, you try something else. But you can still form a somewhat meaningful steps, I guess, and that's what I'm trying to do here. In this here structure, I'm calling it a general factoring strategy. So the first thing is, if a common factor exists, then you try to factor out the GCF. This is always good because, let's say you have a number that multiplies everything. It sort of simplifies everything. So that kind of helps. Then check if special form can be applied. So how can you check that? First of all, if there are two terms and there is a subtraction, it's very likely difference of squares, right? If there are three terms, an a square minus 2ab plus b square. Now this is what I mean. Now I cannot generalize that it's always three terms because we looked at an example where there were four and you had to apply a mix of these two, right? But the one that's for sure shot is, for now in this course, for your case, is if you see cubes or sixth powers or ninth powers, right, then it's probably a cube plus minus b cube, right? Because 9 is also 3 times 3, so anything to the power 9 can also be written as a cube. And then, so here in the three terms case, right, that sort of follows here. Is it a trinomial? If it's trinomial, then can the middle term be split? Now from here, later on when we learn about something called the quadratic formula, here if you get the answer no, then we have a different way of factoring. But for now, the trinomials you see will be such that the middle term can be split. And if not, then if you have four or more terms, then you try factoring by grouping. But this, like I said, is not sure shot. And it's not sure shot because, let's move this a little down, because at times you may have to use a mixture of these strategies. Okay, but in general, it kind of helps to think in along these lines. So let's try to apply this to some problems. So that's the first one. But here are my observations I make. So always pause for a while before you try and factor it. Try to think what's happening here. Observations is that it's a trinomial. There are two variables, x and y. Yeah, there's a y in each term and a 4, which means it sort of points me towards the fact that I can use the fact that the GCF here is 4y. And let me make some room here. Move this over to the next page. All right. So that's what I do, the first step. There is a GCF, so I'm going to do that. Make my job a little easier by getting the GCF out of the way for y. So if I take out a 4 and a y, I'm left with x squared. I take out a 4 from negative 16, I'm left with negative 4. I take out a y from xy, I'm left with x. And then finally I take out 4 from negative 20, left with negative 5. All right, so that's good. Now I make further observations. I observe that this is there are no squares, right? As in 5 is not a perfect square, so this cannot be written as something squared. In addition, there's a negative. So which means I'm going to try and split the middle term. That requires me, recall, to find two numbers such that the product is -5. Now that there's only two ways of happening. And I check the sum is either 4 or -4, which is what I want. Which means that this thing that I have in the parenthesis, I can split this as -5x plus x minus 5. And then I factor by grouping. This is x minus 5 plus 1, x minus 5, 4y, x minus 5, x plus 1. That's the factoring. So we did GCF, then we made the observation that this is not some square or some special form. Instead, it is splitting the middle term. So we split the middle term and then we factor by grouping. All right, let's look at this next one. So try and make your observations. Pause the video and try and make observations about it. Observations, 4 terms. 4 terms immediately should give me the idea that it's probably going to be grouping. Okay, especially because 2 of them have x and 2 of them have y. So let's try to group them. So let's take the x terms together and try and group the x term once, and take the y terms together. So I moved it around because here I can factor out an x, and here I can factor out a y, and that's good news because the grouping is working, because this means I can now factor out a 9b squared minus 16 and an x plus y. Now at this point, this is a difference of squares. Okay, so the observation here is, wait, 9 is 3 squared, 16 is 4 squared. There's a subtraction in between. So that means I can write this as 3b whole squared minus 4 whole squared times x plus y, which then becomes 3b minus 4, 3b plus 4, and x plus y. So again, so we are here, two things that we are applying are grouping and difference of squares. So like I said, there can be multiple combinations of techniques you use to get to the factored form in the end. Let's look at one more problem. Now, because we have been dealing with algebraic expressions as also areas, here's a problem somewhat related to it. It says express the area of the shaded region in factored form. So first of all, the area of the shaded region, what is it? It's actually area of the rectangle minus area of two circles. But these circles, they have the same radius x, which means this is just 2 times the area of one circle. Okay, now to find the area of a rectangle, I need the sides. Now here, if you look here, let's use a different color. If this length is x, then this length is the radius is also x, and this length is also x, so this length is x plus plus x, which is 4x. Similarly, this is the radius, so it's x, and this is the radius, so it's x. So this length now is x plus x, which is 2x. So area of the rectangle is 2x times 4x minus 2 times area of a circle is pi times radius squared, and the radius is x. So this is pi x squared, which becomes 8x squared minus 2 pi x squared. But then it says to write it in factored form. And because of all this squaring and subtraction, what is the, it is, okay, so in this case, we are going to just do GCF. So it becomes x squared 8 minus 2 pi. And that's going to be the end result. No more factoring involved in this one. And that's good to be written as the final answer. All right, that's it for factoring. That's the end of our discussion on factoring as far as this course is concerned. Thank you.